Welcome to the video. Let's take a look at the chi-square test of goodness of fit. And looking at our sample question, we have a report published by Yale University claiming that the proportion of Americans who get their news primarily through online newspaper or television sources, respectively, are 45%, 15%, 30%. Following the publishing of that report, an independent study was conducted. 200 survey respondents were asked the same question, and they reported 97, 22, and 81, respectively. Using alpha of 5%, performed the chi-square test to determine if the sample findings support the distribution claimed by Yale. So in this case, we're going to be working with one sample of size 200 and these frequencies and comparing it against a known proportional distribution. So the proportional distribution claims that 55% of all respondents should take online if that distribution is accurate. So what we're going to do now is figure out how close this sample did come to these proportions, and if it is fairly close, then the test will tell us that it statistically equals. Otherwise, it'll say that there's evidence that it does not equal. So in order to do this most efficiently, what we're going to do is use a goodness of fit table like this. So we're going to list every category over here and then fill this in as we go. So we'll explain that as we work through the setup here, and let's get started. So the first column we're going to have is our observed values column. So I'm going to go ahead and write an O up here to represent observed values, and down here I'm going to jot the sample size. So the N is 200. I've just moved this down here, and the next thing we're going to do is calculate our expected values. So two values that go into making up this test statistic: the observed value, which is the actual frequency, so this is always going to be a count of items that were observed in the sample, and we're going to compare those values to the expected values, which we get by multiplying the sample size times that category's expected outcome. So in this case, 55% of 200 elements would be 110 elements. So if our sample happened to come out exactly matching this proportional distribution, the number of respondents saying newspaper would be 15% of 200, or 30. And finally, 30% of 200 would be 60. So we'll double check our math. These add up to 200, 110, 140, 200. These add up to 200. So our next step is to calculate the difference between each observed and expected value pair. So here, 97 minus 110 gives us negative 13, 22 minus 30, negative 8, 81 minus 60, 21. Next thing we're going to do is square those values. 13 squared is 169, 8 squared is 64, 21 squared is 441. And the last step in our table to build our chi-square data value is we take that difference squared that we just calculated and divide it by the respective expected value. So here, 169 divided by 110 equals to 1.54. So the difference between the observed and expected online category is going to contribute 1.54 chi-square units to our data value. Likewise, we'll divide 64 by 30 here. 64 divided by 30 is 2.13, and 441 divided by 60 equals 7.35. The final step in computing our data value is to sum up all of these square differences divided by expected values. So 1.54 plus 2.13 plus 7.35 is 11.02. So that's our chi-square data value. Knowing that, let's go ahead and set up and perform our hypothesis test. Alright, for this goodness of fit test, what we're going to do is we're going to first list the reference distribution, or the distribution that we're comparing our sample against. And here I'm saying that the proportion of online respondents is 55%, or is expected to be. Proportion of newspapers 15%, and the proportion of television is 30%. And for the alternate hypothesis, we're going to flip that around and say that the random variable does not follow the distribution in the null hypothesis. Alright, good. Alpha is 5%. We're given. We're performing a chi-square test here. And step number 4. We already have our data value figured out from above. We know that's 11.02, and let's come up with the corresponding crit value. So for the goodness of fit test, we need to go to our chi-square table to get that critical value. To do that, we need the degrees of freedom. Degrees of freedom in this test is the number of outcome levels minus 1. So here we have 3 outcome levels, therefore our degrees of freedom is 2. So let's grab our chi-square chart, degrees of freedom 2, and area in right tail 5% gives us a critical value of 5.991. So we'll move down our 7-step list here. Why don't we go ahead and sketch out our distribution. So here we have chi-square crit of 5.99, and our chi-square data is off to the right of that. Our rejection rule is reject H null if chi-square data is greater than chi-square crit. In this case, chi-square data is greater than chi-square crit, so we're going to reject H null, and we are then able to say that there is evidence that the sample distribution differs from that provided by Yale.